Naming the substituents on a very special molecule named benzene. Benzene is a very special molecule known for its stability, geometry, and what's considered aromaticity, which is a fancy word to describe the electron stability of the pi set. It has the formula C6H6, and here is a stick line drawing, cartoon of benzene. Each corner represents a carbon. Hydrogens are not drawn. Carbon bonds 4 times most of the time, pretty much every time. This carbon is bonded 3 times already with 2 sigma bonds to other carbons and a pi bond to this carbon. So the 4th bond that's not drawn is a hydrogen coming flat out to the side. Now, benzene, this picture actually does accurately represent what benzene looks like if you could see it with your naked eye. This is a stick model kit. I also don't have hydrogens on this just for clarity, but there are 6 hydrogens coming out right here. It looked like a nasty ninja star with all the hydrogens coming out here. Note its planarity, how plain and flat it is. This molecular characteristic is carried on in substances like graphene, where you have millions of benzene molecules linked together, having that flat surface right there in graphene or graphite. Now, when naming substituents around the ring of benzene, we have some Latin names that help with that. So, for example, this arrangement where we have 2 chlorines on the benzene ring, where they are right next to each other. This is called, you could call this ortho or 1,2. Ortho meaning they're right next to each other, and 1,2 being right next to each other right there. Note, looking at this model here, note when you turn it, they are ortho to each other right here. This is sometimes confusing, being able to turn the molecule and flip it in your head right here, but this is an ortho configuration. The 2 atoms, the 2 chlorine substituents are right next to each other. Still next to each other, still next to each other. Now, if it is in the 1,3 position, we call this meta. And the 1,3 position, so counting the carbons, 1 and 3. No bond is broken, but if I flip it, this is also in the 1,3 position here. Counting the other way, 1, 2, 3. Remember, we always count our locant numbers to get the lowest possible sum of numbers. To count this 1, 2, 3, 4, 5, it's not the best answer. I wouldn't say it's wrong because somebody could probably figure out your mistake, but it's not grammatically, hieroglyphically in line with chemistry. Keep your counting numbers the lowest possible. When in doubt, count both ways, pick the lowest answer. So ortho, meta, and there's one more position, and that is directly across from each other, para. These are what some of the Latin, these are, as I said, these are Latin names, and that's what some of these meant, that's what some of these mean. Ortho next to, para, ortho next to, meta, about, para, opposite. I don't know if I have that meta translation, absolutely correct. But when something is para, it's opposite, ortho next to. So para is 1, 4. 1, 2, 3, 4. A 1, 4 locant. So this could be 1, 4 dichlorobenzene or para dichlorobenzene. Note when we turn this or flip it, it's still in the 1, 4 position. There are 2 carbons in between the substituents. I hope this helps. Thank you.